So I'm not even going to focus on that right now. So if tangent of 30 degrees is about 0.58, then it follows that if the tangent of an acute angle is 0.58, then that angle is 30 degrees. Okay, so we can take the opposite. We're going to do the opposite direction today. Okay, so before we were finding a side length, now we're going to find angles. So the inverse of trig ratios is finding the angle measure given the trig ratio. Okay, so on your calculator, most of you will use the second key or the shift key to find the inverse function. Okay, so on your calculator, you have a second button and you have a shift button or a shift button. You don't have both. Okay, second or shift. And this is to find the measure of the angle. So to set this up, our angle is always that capital letter A, right? We always have an angle attached to sine, cosine, and tangent. So if I want to find what that A value is, and I'm given sine of A is equal to X, and I want to find what A is. I want A by itself. You cannot just divide by sine. Okay, that sine is attached to that A. So what we do is bring in the inverse function. So we bring in sine inverse to both sides of that equation, because that sine inverse and that sine will cancel each other out. That way I'm left with A is equal to the sine inverse of X. Okay, and I'll be able to plug that into my calculator to get your angle A. Okay, that's true for cosine and tangent as well. So we are just going to practice this. So in number 1, we want to find the indicated measure to the nearest tenth. So number 1, we want to find angle A. Okay, if I'm finding angle A, I always circle whatever angle I'm going to find. Okay, so I need to find that angle. I look at the two sides of my triangle that I'm given, and I want to label those so I can decide which of my trig ratios to use. So from angle A, I have this side of 18 and this side of 27. Okay, well, I know 27 is what? Is the hypotenuse. Good. Okay, then this side of 18 is across from my angle that I'm working with. So it is the opposite side. Okay, so I have O and I have H. Okay, that would be sine. So I would be using that SO piece of SOHCAHTOA. Okay, so I'm going to use sine. And I'm going from angle A, so I'm just going to use A. Because I don't know that angle measure, I have to try and find it. And that's equal to my ratio of sides, which is O over H. Okay, so O is 18 over H is 27. Now again, to get A by itself, we have to bring in that sine inverse to both sides of the equation so that I can cancel out the sine on the left-hand side. Okay, and that little -1 there, it does mean inverse. It's not raised to the negative first, it's the inverse symbol. Okay, so on the left, those cancel. So I have A is equal to sine inverse of 18 over 27. Okay, so this is the part where you get to use your calculator. Now that I have A by itself. So following along here, what I'm going to do, you see sine right here that we were using before? Right above it, printed on the calculator itself, you can see that sine with that little -1. That's your inverse sine. So to get that button, you have to press second and then press sine, and it should show up for you. Okay? And then I can just plug in my fractions, so 18 over 27. Press equals to get 41.8. Okay, so A will equal 41.8. And that is in degrees because we're finding that angle measure.
There's some like calculus stuff.
It's trig. Okay, questions on number 1. I'm going to do it again in number 2. All right, so then number 2, we want to find the measure of angle B this time. So that means I'm going from angle B. So I'm going to circle that angle so I know that's the angle I want to find. Okay, next I want to identify the two sides that I have. So if I'm going from angle B and I have this side of 20 here and it's across from that angle, that has to be your opposite side. Okay, then I have this side of 6, which is right next to my angle. That's not the hypotenuse. That's called the adjacent side. Okay, that's the side next to your angle. So I have O and I have A. Okay, so I'm going to use tangent. So tangent is opposite and adjacent. Okay, so to set this up, we're using tangent. Okay, of the angle we're going from, we're trying to find angle B. So I would say tangent of B is equal to my ratio of sides, and that's O over A. So 20 over 6. Okay, from here I'm going to bring in the inverse. And I have to do tangent inverse this time because I was working with tangent. Okay, so tangent inverse to both sides so that they cancel out on the left. So we have B is equal to tangent inverse of 20 over 6. And then I can just enter that into the calculator. Okay, so I want you to try and enter that into your calculator right now.
So you guys just don't care about that. Wait, you didn't yeah.
Okay. I don't know, how does the fraction work for you, Rick?
Not for you. You make the challenge.
Hey, that's well.
So you guys this, right? You guys don't. Yeah, I know. That's gonna be so.
All right, you should have gotten about 73.3 as you entered that into your calculator. Okay, so angle B is 73.3 degrees. Questions on number 2? All right, I want you to try number 3. Try number 3.
My brain is too stupid for this.
Then you're pressing 7 Yep.
Where is O? Is back in front of O.
Yeah.
I don't know.
Now, the other side that you have is right? Is that the opposite side? So you're trying to find A.
Oh, here.
And
I'll say this, so it's
what
C
side?
and then A over
You
here.
have opposite side, hypotenuse, and then the other side. How do you measure what opposite side? No, what's always opposite than 90? So I would label that with an 8.
So wait. No, the
Did you get an A?
Oh, I was gonna say that I don't have to do it. So my other side then.
Nice.
And then we use SOA, the time.
I knew it was right.
So that would be the
I was glad. You guys got one.
Did you get 11.5? Oh, that's right. What did you get? How? I got like a 1 contraction.
I need cosine minus the cosine of the switch. And then I did 3 divided by
That's what I did.
already did 200 up.
Wait. Wait, how many? But this must be his.
Ryan, I went into this not what? I went into this knowing I was going to lose. Why? Because I don't have
Hey, it's ball. Is the answer 11.5?
Let's do it first time too.
I was looking back at number 1. How is that not?
Why? I have
But
fun
yeah,
all
so
of these.
for number 4. Well, I don't. How am I supposed to know? How am I supposed to know this?
You just have to decide between 3 sides.
What weird? Come back here. How do I know which side is which?
But then I was right. I don't know.
What's this?
I don't know where it is.
I don't know either. I don't know. What are you talking about?
So what's the?
For the third one?
Everything here is
78.5.
But what's the equation?
It is right.
So you use Coca-Cola and time is over H. And I didn't know sign is A over H. Tangent is over A.
Because I had the other one with the other person, and I was like, I don't know.
All right. Coming back together here. You should be using Sobatol. If you need to write this back down on your paper somewhere, you do that real quick before I erase it. For number 3, you should be using cosine. Okay, you should be using cosine because you have an adjacent side and the hypotenuse. So we're doing cosine of A is equal to 3 over 15. So you should have A is equal to cosine inverse of 3 over 15. And then your angle measure you should get to be 78.5 degrees. All right, questions? Setting up these problems. You're still getting that practice with finding which sides you have. Okay, so still trying to find opposite, hypotenuse, and adjacent. Shh. Quiet now. All right, so then if we move to the back here. So now that we know how to use the Pythagorean theorem, right? A squared plus B squared equals C squared. Pythagorean theorem. We know how to use trig ratios, and we know how to use the inverse of trig ratios. We can do what's called solving a right triangle. Okay, so to solve a right triangle, that means you're finding all the angle measures, every single angle in that triangle, and all the side measures. Okay, so all the angles and all the sides. I have this handy dandy table there for you to write them all in. Okay, so in number 4, I have this table here. So we need to find all of our angles and all of our sides. Okay, so I have to find the measure of angle X. I have to find the measure of angle Z and the measure of angle Y. For my sides, I have to find the length of XZ. I have to find the length of ZY and the length of XY. Now, for some of these, I'm already given those measurements. Okay, for my angles, I know angle Z. Okay, that's 90 degrees. So I would write 90 degrees for angle Z. For my sides, I'm given XZ is 5. I'm also given ZY is 9. Okay, so I should never get those problems wrong on a quiz or test. Okay,
Oh,
they
wow.
are already given to you. Okay, make sure you write those down right away. So what we're going to do is find the other one side. Okay, we have to find one more side, and we have to find 2 more angles. First thing I do, if I have 2 of my sides of a right triangle, what can I use to find the third side? Go ahead, Dawn. The Pythagorean theorem. Good. So my first step here, okay, first thing I'm going to do, I'm going to use the Pythagorean theorem. So a squared plus b squared equals c squared. Okay, my c value is this one over here. Okay, that's the only side I'm missing in this right triangle. To plug in my a and b values, that's 5 and 9. So we would have 5 squared plus 9 squared is equal to c squared. Okay, so I'm just plugging things into that Pythagorean theorem. So we have 25 plus 81. Okay, that is 106.
Finally, something I can do.
Okay, and then to get c by itself, you do need to take the square root of both sides. So I get c is equal to about 10.3. Okay, now that c value I labeled as x, y. Okay, so that's 10.3, and I can now write that in my table. Okay, next, I need to find the last 2 remaining angles. Okay, last 2 remaining angles. Well, we just learned how to find an angle in a right triangle using trig ratios on the front. Okay, so I'm going to next, I'm going to solve for angle x. Okay, I'm going to solve for angle x right here. And I'm going to use my 2 sides that I didn't round to get an answer for. So that would be this side of 9 right here and this side of 5. So I want to label those sides from angle x. 9 is across from that angle. So that is your opposite side. Side that has 5 here is the one right next to angle x. So that is your adjacent side. So I have O and A, so I'm going to use tangent. Okay, so I have tangent of x, because I'm finding angle x, is equal to, the opposite side is 9, over the adjacent side is 5. Okay, from here we just do what we did on the front. You bring in that inverse. So we have tangent inverse to cancel out that first one, to get x is equal to tangent inverse of 9 over 5. And that should be about 60.9. Okay, so in my table above, for the measure of angle x, I can write 60.9 degrees. Now for the measure of angle Y, you can do it similar to that, or there's an easier way to find angle Y. Do you know what that easier way is?
I mean, you just switch the numbers from the denominator to the numerator to the denominator.
For the other tangent one? Yeah. You could do it that way.
You got it. That's
Anybody else know what the easier way is? Does anybody know?
369.
Does anybody know what all of the angles in your triangle have to add to be?
90.
180.
180. All of your angles in a triangle have to add to 180. Okay, so to get my last angle,
This would be
all I'm going to do is take 180 and subtract the two that I already know.
119.1.
Subtract 90 and 60.9. Both angles. Okay, so subtracting 90 and 60.9 from 180. You get 29.1.
Close enough.
I wasn't laughing.
You just forgot the 90. It's okay. All right. So
I was talking at the fact of
we don't always get both sides, okay, where we have to use the Pythagorean theorem. Sometimes you're given two angles and one side. Okay, so you can still use each of these equations. You can still use your trig ratios. You can still use the Pythagorean theorem once you find another side. Okay, but you kind of have to put it all together. Okay, you have to put that all together. So we're going to do it one more time in number 5. Okay, we're going to solve this right triangle below. But first, do you guys have any questions on number 4? Okay, further explanation in number 4.
No.
All right, well, I'm going to do it again in number 5 if you do. So, again, we want to fill in this table here. So I have to find the measure of angle P, the measure of angle Q, and the measure of angle R. For my sides, I have to find PQ, I have to find QR, and I have to find PR. Now before I start any equations here, start setting up any type of problem, I'm going to write what I already know in my table. So I know PQ, that side, is 16. I know this angle Q is 90. And this angle R here is 33 degrees. Okay, so now I need one more angle and I need two sides. Okay, one more angle. What's the easiest way I can find that last angle?
Minus 180.
Subtract from 180. So that's going to be my first step here. I'm going to take 180, subtract 90, and subtract 33 to get 57. Okay, so that's going to be angle P. That's 57 degrees. Okay, so now I just need the last two sides. Okay, last two sides. So I'm going to label these. I'm going to label the side opposite angle Q as lowercase q. You can label it as C if you want, doesn't matter. And the side opposite angle P, lowercase p, just so I know that they're opposite sides to those angles. So now to find one of those sides, I have to use trig ratios. Okay, so I have to use trig ratios to do that. I'm going to go from this angle of 33 here. Do you want me to find P or Q? Which one?
Q.
Q? Okay. So Q is what label according to this angle? Opposite, adjacent, hypotenuse. It is the hypotenuse, right? Okay, the other side that I'm given that's not a variable is 16. From this angle of 33 degrees, I have to go across to get there. So it is opposite. So I have O and I have H. Okay, that is sine. Okay, so my second step here, finding lowercase q, I'm going to use sine of the angle that I went from. Okay, that is 33 degrees. So I need to plug in 33. That is equal to your ratio of sides. So your opposite side is 16 over your hypotenuse is q, or you can use h. Doesn't matter how you label it, just as long as you know what's going on. Okay, from here, this is what we did yesterday. What do I have to multiply by? The denominator. Good. So I'm going to multiply by q on both sides so that it cancels out over here. Multiply by q on both sides. So we have q times the sine of 33 is equal to 16. Now I want q by itself. What do I have to do? Divide. Okay, so I'm going to divide both sides by sine of 33. So I have q is equal to 16 divided by sine of 33. And you can again plug that into your calculator. Okay, you can plug that into your calculator to get a number for q. So when you are solving for sides of a triangle, you do not use an inverse. Do not press second and then sine. You don't use an inverse if you're solving for sides. You only use an inverse if you're solving for an angle. Okay? So once you enter this into your calculator, it is 29.4. So you should get about 29.4. So looking back up at my table here, I labeled this side Q, that was PR. So side PR in my table here should be 29.4. Now if I have two sides of a right triangle, again, what can I use to solve for the third? You can use the Pythagorean theorem. If you like trig ratios better, you can use trig ratios. If you like the Pythagorean theorem, you can use the Pythagorean theorem. It does not matter which you use. So, we can use the Pythagorean theorem to find that final side of P. Okay, so our A and B values are 16 and P. So we have 16 squared plus P squared is equal to our C value is this Q, which we just found to be 29.4. So 16 squared is 256. And 29.4 squared is 864.36. Then we want to subtract 256 from both sides to get P squared by itself. That's 608.36. And then to get P by itself, we just need to take the square root of both sides. Okay, and I got about 24.7. Okay, and that would be your final side of QR. So I can put 24.7 in my table to finish off that triangle.
I think I just have my brain.
Your brain exploded?
I have a cheap actual brain test. All
right, so
like for only 10 more seconds.
questions on solving your right triangle on the back? All right, so what I want you to